Right, so today I'm going to discuss a work, energy and power related problem, right? So now here we have the vehicle, right? Or in other words, the automobile, right? So if you're going to consider automobiles, right, there's a special device called the engine, right? So this engine provides the necessary driving force, or this engine provides the necessary mechanical energy that is required to overcome all the driving conditions and all the resistive forces, right? Because if you're going to consider driveline dynamics, there are several types of resistive forces, right, that a vehicle has to overcome, right? So this problem is basically based upon how to calculate the required driving force provided by the engine, right? So now let's focus the problem, right? So now in this problem, right, it is given us that the travel distance is 500 meters along this inclined road, right? And the final speed that the vehicle is attained is given as 20 meters per second, right? And the road inclination is defined as alpha, where sin alpha is given as 1 divided by 20, okay, right? And the resistance force or the resistive force is considered as a constant force, right, where the resistance force is acting in a direction such that it is opposite to the direction of motion, right? So here in this problem we are going to consider the resistive force as a constant force, right? Okay, so then let's calculate what is the driving force provided by the engine, right? So in this problem we specifically need to calculate the driving force provided by this engine in order to reach state 2 from the state 1, right? So what is state 1 here? So state 1 is when the vehicle is entering to this inclined road which is at an inclination of alpha at a velocity of 10 meters per second, right? So then after a travel of 500 meters, right, the vehicle has reached to the state 2, right? So at state 2, the velocity of the vehicle, the velocity that the vehicle has attained is 20 meters per second, right? So that is the scenario, right? So now here during this travel, right, so during this motion, in the problem it is said that there is a constant resisting force, right, that acts in a direction such that it is opposite to the direction of motion, right? Because like when you are going to consider a vehicle, there are lots of resisting forces that actually resist the motion, right? For example, rolling resistance, aerodynamic drag, right, gradient resistance, right? So like that. So now when you are going to solve this problem, we are going to consider that all the resisting forces, the resultant of all the resisting forces to be the same value, right? So that value is 300 newtons, right? So it is acting there. So throughout this travel from position 1 to 2, the resisting force will be the same, right? So because of this resisting force, the engine has to do some work in order to overcome this resistance, right? So there should be some sort of a work done to overcome this, right? So what is that required amount of work done? So that is 300 multiplied by the distance, right? Okay. So in order to solve this problem, we need to calculate the total energy gain during this travel, right? That means with respect to the position 1, what is the total energy gain at the position 2, right? So let's write an equation for that. So let's write an equation for that. Total gain in the energy, right? So that equals, right, total gain in the kinetic energy Ek plus total gain in the potential energy, right, plus let's say required work to be done in order to overcome the resisting forces, right? Resisting forces, right? So equals, so what is the gain in kinetic energy? Half times m times velocity at the state 2 squared minus the entering velocity v1 squared, right, plus, so if you are going to consider this state as the reference level, right, so there will be no potential energy at this level, but after traveling 500 meters at this position it has gained some height. So what is that height? That is x. So there is a very simple way to calculate that. You know that sine alpha is given. So sine alpha equals x divided by 500, right? X sine alpha x divided by 500, and it is given as 1 divided by 20. So 1 divided by 20 equals x divided by 500. So very easily we can obtain x equals 25 meters, right? So what is the gain in potential energy? mgx, right, plus what is the required work to be done in order to overcome the resisting force? So now here this resisting force is a value, right, 300 Newton. So let's consider a letter for that. So let's say the resisting force is Fr, right? So then what is the required work to be done in order to overcome that? Fr times the distance, because this distance, so let's call that distance as d, because later we will put the values. Resisting force multiplied by distance, because force multiplied by distance gives you the required work to be done in order to overcome that resisting force, right? Half mv2 squared minus v1 squared plus mgx plus Fr times d, right? So as you know the formula, total gain of energy is half, what is m, 1000, v2 squared 20, 20 squared minus 10 squared v1, then gain in the potential energy m 1000, g let's consider it as 9.81, mgh, what is h, this height 25, plus the work done against the friction, or the required work to be done in order to overcome the it's not friction, to overcome the resisting force, right? Okay, but here it is not only the friction, there are some other resisting forces that are associated with. So plus force times, what is the force? 300 newtons, force times the distance 500, right? Right. So check whether when you are substituting the values, whether the units are okay, right? Right. So then what would be the answer? If you carefully do your simplifications, the answer would be, so if you carefully do the simplification, the answer will be 545 250 joules, right? So this is the ultimate gain in energy when state 2 is reached from the state 1. So that is why here specifically we are considering half mv2 squared minus v1 squared, right? Okay, so that is the most important part over there. So the total gain in energy when it is reached to the state 2 is 545,250 joules, right? So now that total gain in energy, right, must be provided by the engine in order to reach to state 2, because otherwise there is no any sort of other option to gain that energy, right? So we can say that total gain in energy, right, must be same as the energy provided by the engine. Energy provided by the engine. So what is the total gain in energy? 5, 45 to 50 joules. So what is the energy provided by the engine? That is driving force. What is the driving force? Energy equals driving force Fd multiplied by that particular distance that it travels. So that distance is d, which is 500 meters, right? So then what is Fd? Fd equals 545 250 divided by 500, right? So what would be the answer? If you carefully do the simplifications, the final answer will be 1090.5 Newton, right? So that is the driving force provided by the